Okay, ladies and gentlemen, welcome back. Today we're going to cover the laws of the exponents, just 3 of them. So this is Dr. Daniel D. Robinson, and we're going to talk to you today about the laws of the exponents. So here's the first one. In multiplying, when the bases are the same, add the exponents. The bases, what does that mean? That's the number that's underneath the exponent, the big number. For example, 5 would be the base. 5 times 5 times 5 times 5 times 5 times 5 times 5. So they're talking about all of those 5s. Those are the bases. The exponent is not displayed here, so it would be 1. One little 5, or one big 5. Here's another 5. Here's another one, so on and so on. If you count up all the 5s, there are 7 5s. What we did was we added up all the 5s, or counted them all up, and it added up to 7. So the base is 5, it remained the same, and there are 5 of them. That would be 5 to the exponent of 7. We could have a letter as a base as well, where A would be the base, and again, there is no number 1. 1, by the way, is the only number in algebra you don't have to write. So there's an imaginary 1 up there. So times A times A times A. So if you count up all these A's, there are 4 A's. So the 4 is the little number on top, the exponent, and the A is the base. So again, in multiplying, when the bases are the same, add the exponents. So there would be a problem that you might want to try out on your spare time. You may pause it and try it out. But this one, I notice you're dividing. All these 2's being multiplied, dividing by 2's, which leads us into law number 2. In dividing, when the bases are the same, subtract the exponents. So for example, 5 to the 17th divided by 5 to the 10th, we're dividing 5 to the 17th, which is a big number, 5 times 5 times 5, and so on, 17 times, divided by 5 to the 10th power, which is 5 multiplied by itself 10 times. There's a shortcut. Since we're multiplying all these 5's and dividing by a bunch of 5's again, we can just subtract those 5's by subtracting those exponents. 17 minus 10. So we're cutting off 10, or canceling out 10 of the 17 of the exponents, and that'll leave us with 7. So 17 minus 10 gives us 7. So our base would stay the same. We do nothing to the base, but it's the exponents that we're concerned with. So again, here's another way we would write division as a fraction. 4 to the 7th divided by 4 to the 2nd. All we have to do is subtract the exponents. 7 minus 2 would give us a new exponent of 5. You could write it out in expanded form and cancel out, and you'll see what's left. There would be 5 4's left. 4 to the 5th power would be the answer to this one. So that's law number 2. So again, in dividing, when the bases are the same, subtract the exponents. Here's our next problem. You could try that in your spare time. 2 to the 3rd power raised up to the 5th power. A power to another power. Be nice to see that in expanded form. So this is law number 3, a final law we'll deal with. When raising a power to a power, bases are the same, and bases are the same, multiply the exponents. So we're raising 2 to the 3rd power first, and raising that to the 2nd power. Well, we could write 2 to the 3rd power twice, because this says the exponent is 2, and we write what's inside twice. That would be 2 to the 3rd power, 2 to the 3rd power. And then we would add the exponents because the bases are the same. But here's a quicker way of doing that. 3 times 2 would give you 6. So 2 to the third power times 2. So we multiply the exponents. 2 to the third, 3 times the 2, and that gives us 6. So let's practice. Find the value of 5 to the second power times 5 to the second power. What do you think it is? A, 25 to the fourth power. B, 25 to the second power. C, 10 to the fourth power. Or D, 5 to the 5 to the fourth power. Give you 30 seconds. And I know you said A, which is absolutely wrong. What? Wrong? That's right, it's wrong. You remember, you keep the bases the same, so 5 stays the same. So that means your base has got to be 5. Which one has a base of 5? That one has a base of 5. What do you do to the exponents? That's right, you add them. 2 plus 2 is 4, so the correct choice answer is choice D. Let's try again. Whoa! Find the value of 4 to the second times 5 to the third times 4 to the third divided by 5 to the second times 4 to the fourth. Wow. And they give us a lot of interesting choices. So you pick one, see what it is. Now I'll give you a little hint. I would get together my answers, like my 4s, I would put those together, 4 to the third and 4 to the second, I get those together and see what that is. And I notice it's being divided by 4 to the fourth power. So I would see what that is. Then I got 5 to the third power over 5 to the second power. So you remember what happens when you have this division sign. So we're going to talk about that tomorrow. Check for your understanding. See if you understand how to do this. If you're uncertain, rewind the video, play it again. If you're uncertain, please write down your questions, talk to me tomorrow, and we will continue with this. So I hope you got something out of it. I want to make sure to answer your questions, so write them down. Make sure you've taken good notes, and I will see you tomorrow in class. Bye-bye.